Hello and welcome to the next video lesson. Okay, I've been doing a little bit of work. I have modified my fake data to have exactly 5 pieces of information. We don't need 1,000 for this, but I have gone through and I've refactored everything. At least I think I have. I haven't actually had a chance to try it yet. But what I've got is I'm now using this map because we know that using a map is probably going to be faster, and everything is served up locally this time. So we don't need any of those asynchronous things. I mean, if you want to, you can certainly go off and try it, but there's just absolutely no need for it. Okay, and what I've done is I've just kind of hacked out a bunch of stuff just to try and reduce the size of this. Like, I've gotten rid of my allowed entry, I've gotten rid of my get details. The only thing I'm going to include here is this thing called authenticate, and I'm going to do that in a little bit. Okay, and of course the important thing here is I've gone into my data and I have added some passwords. Okay, so you can see this first password, somebody has used the word let me in. This person has used the password 12class34. Like, that's kind of almost expected, isn't it? Somebody else has used the password. It looks like this person here has used Fluffy, probably their cat's name. And finally, this person right here has just used the string QWERTY. So obviously not very secure passwords, but that's fine because these can at least be used. Okay, so let's go off and let's start doing a little bit of work on the main index page. So it's a little bit of HTML work for a few minutes, and don't worry, you'll actually get to see this. And then what I'm going to get you to do is I'll get you to stop the video, and I'll get you to do some of the implementation it's going to take a little bit too much time for me. Okay, here's what I'm going to do over here. First of all, I'm going to have a div called the login screen. Okay, and this is going to have a bunch of stuff on it. So what would you see on a login screen? Well, you'll probably see something like a username, which would be some kind of an input. And I'll just use a break. And of course, we'll probably have a password. Again, I'll just use an input and we use a break. And we'll stick a button on here to actually make it happen. Okay, so login button. So let's take a look and see how this appears. Okay, so that's quite reasonable. All right, and what I'd also like to have is I'd like to have a div called ID, and we'll call it customer screen. And what this is going to have, some information about the customer, so customer details, okay, and that will be filled in a little bit later. And of course, right now, I don't want to see the customer details because this shouldn't be around unless the person's able to actually log in. So what I'm going to do is let me come up here to the style and let me take the customer screen, and we'll use that trick we used before, which is display as none. Okay, so now it disappears, and the idea is that if the person gets logged in correctly, then I want that screen to appear, and of course I want the login screen to disappear. Okay, well, we've done a bunch of that stuff before. But before we get there, a couple things about this. Okay, well, one of the things is, well, we don't want to have just the word input. We better actually have an ID. So let's call this the username, and we'll call this one the password. ID is password. Okay, and of course something needs to happen when this goes on. So let's say on click, we'll call it attempt login. Okay, here we go. Attempt login, and we'll come over here and we'll add one extra function called attempt login. So function attempt login, and hey, it's going to be exactly as we expect. So first of all, there's the username. So let's have let un for username be document get element by ID username, and yeah, we'll kind of trick our way and we'll just ask for the value this time, not node value, just value. Okay, just value, and let's have the PW be document get element by ID. If this is the only place we're using it, then maybe it's not so bad. And what did I call this? Did I call it password? I called it username and password directly. Password. Also dot value and username. All right, and all we're going to do is we'll just say console.log attempt to log in, and we'll print out un, and we'll put a comma, and we'll print out the password to make sure this switch is working. Okay, so let's load this up, and we'll type SSS, and we'll type 123 for the password, and SSS and 123. Okay, that's good enough to get started. Okay, now a couple things about this page. All right, before we even go off and try to authenticate, this probably isn't such a good idea to allow people to work. It would certainly be better is as you type, you can actually see the thing. Because, of course, well, that's the way how anything works. Like, I'm sure if you put in here, for example, if you type your password, you don't see anything, so what gives? Okay, well, it's quite simple. The format of this thing, we simply have the wrong type, because remember that if you don't give a type of an input, it's a regular text input, but there's a bunch of other types available, and one of the types is actually called a password. Okay, and guess what it does? It doesn't actually show you anything. Okay, so let's go, sorry, wrong place. Let's load up this one. So SSS, and if we type 1, 2, 3, 4, at least now we're only getting the dots. Okay, but we still have access to the 1, 2, 3, 4. It's just that it doesn't get displayed. So that's probably a better option. Okay, so what I'm going to get you to do is, this is probably a reasonable point for you to stop. So I'm just going to say, pause this video, so it's not at the end of this video. Add the username and password fields to your index.html file, and if the username and password combination, okay, press enter to get down to the next line, password combination is valid, then show the user details screen. Of course, the user details screens don't show anything. It just says user details. Okay, so please pause the video, and what I'm going to do is I will leave it here for a few seconds, and then I will be back and I will walk you through my solution. Okay, and I'm back. All right, so let's walk through the actual implementation. Okay, it should be very simple. Okay, so now we've got the username and password. It really is just as simple as going to the CMS and asking to validate. Now, do we have an actual function to validate? No, we don't, because right now it says false. So let's actually have a function down here called authenticate. So you get a CID, which is the username, and a password. Okay, and the way how this is going to work, well, we have a list of customers. We just need to go and pull up the customer. So let's C be equal to this customer list dot get CID, because remember, we don't need to find anywhere because it's not an array, it's now a map. And we start asking questions. Okay, first of all, if not C, what do we know? That's definitely not valid. Okay, that's just completely gone. Otherwise, what we can do is we can ask the question about whether or not C's dot password happens to match the PW that was just handed in. Okay, so we'll come down here and we'll ask the question if CMS dot authenticate UNPW. Okay, so if that's the case, then what we end up wanting to do is, let's just do a console.log first. Show the details, and then we'll actually switch it in a second. Otherwise, we'll say console.log, and we'll say show error message. Okay, so let's find out whether or not this much is working. Here we go. Okay, save it over to here, load this, and if we type a bunch of random gibberish, it says show error message. Okay, and let's actually try a valid one. Let's try this name right here, 40-0617406. I'm definitely not going to remember that. Okay, and let me just type some random junk and make sure that I see the same show error message. Okay, that's good. And if I say the word fluffy, it says show the details. Okay, so at least my authentication part is working. So hopefully you had that already done. So what would this mean to actually show the details? Okay, all that I'm going to do is I'm going to do this. Let me grab the element by ID. Yes, I don't like this. I would prefer if we actually did some other things. Let's take the login screen and we'll take the style to display, we'll make it equal to none, and we'll make document get elements by ID user details and style display block. Okay, but yes, I would probably actually have that stored as a variable so I didn't have to look it up each time. Okay, and instead of show console or instead of show error message, we have a couple of other options. Okay, so what we could do here is let's just use an alert, but probably what I would end up doing is I would likely end up having like a div right here called the error div, and that's things that would show up. For example, if I go back to D2L, I actually logged in here. Sorry, let me refresh this page. Okay, for example, if I try to type in some stuff right here with a bad username and password, you see they're using this ugly looking alert box, so I guess it must be perfectly fine. But most of the time, I think something showing up here saying that, hey, that's not a valid login, that's going to be a whole lot better than having this big pop-up dialog. Any case, but since D2L does it, well, I guess I can do it too. All right, so let's save this, back over to here, let's save this, and let's find out whether or not this is working. So let's go to my page, we'll reload it, we'll put in that username, we'll type a bunch of random gibberish. Okay, here we go, show the error message, okay, and let's actually try typing in a valid password, and here we go. It's not too bad, except that I ended up getting this error message. So it did say show the details. I probably misspelled something, so let's fix that. User details, customer screen. Okay, so it was completely wrong. Okay, let's call it customer screen. All right, so one final try. Okay, load up the page. Okay, here we go, and let's put in proper username and password, and here we go, here's the customer details. Okay, so hopefully that you've already had that, but now we've gone through just in case. All right, so now back over to here, I've got a little bit of security stuff to talk about. Okay, so this stuff that I've done right here, this is part of the course. What I'm about to do is actually not part of the course, but I think it's important you guys actually have a chance to see some of this at some point, because unfortunately, in our program, in the 2-year program, you don't see anything about security. In fact, even the 3-year program, you don't see anything about security until the very last semester. So it's a bit unfortunate you don't get to see it before. So let's take this as a little bit of a preview. Okay, it's not terribly difficult. Take a look at my fake data up here. Okay, the CID of this first person is 99970337320. Fine, I can read that. First name is Helen Elizabeth. Yeah, I can read that. Last name, Jono. Yes, I can read that. Password, let me in. Hey, wait a second. You can actually see everybody's passwords right here. Now, of course, you're going to say, well, it isn't actually going to be stepped on a browser. It's going to be stored on a server. Yes, that is actually true. But again, the last thing that you want to do in a database is actually put passwords like this, because if the database ever gets leaked out to somebody, it means that everybody has the passwords. Okay, so this is not a situation that you want. And what I'm going to do in order to explain the types of things we have to do, I'm going to make a small side exercise. But what I'm going to do is I'm going to get you to come back and I'm going to get you to do this type of thing a little bit later. Okay, so over here, okay, I'm going to hijack my map demo, and I'm going to come into here and I'm going to say map demo, and I'm going to do a bunch of stuff here inside this thing called map demo. Okay, so here we go. Here's a password. Let password equal to let me in. Okay, so there we go. There is the password called let me in. Now, of course, the way how this normally works is you would then, if you would take somebody's password and you would find out whether or not it was exactly what the variable is equal to, but here's a problem. That password is completely visible to everybody who has access to the source code. So what I want to do is I want to make a change. Oh, there we go again. I ended up erasing my notes. I'll have to do this by memory, which means I'm probably going to want to stop this in a few minutes. Okay, what I want to do is I want to encode this password in a slightly different way, so it's at least not completely obvious. Okay, and what I'm about to do is really, really terrible, by the way. It's not to be used for actual passwords. It's only to show you the way how the algorithms work. Okay, so here's what we're going to end up doing. The first thing up is, instead of storing the password directly as let me in, here's what I want to do. I am going to have an extra variable in here called sum. Okay, in fact, we'll get to that in a second. Okay, first of all, let me run through all of the variables of the password. Okay, and unfortunately, I've got to do this in a funny way. Let's let c equal to 0. Well, c is less than password.length, and we'll say c++, and we'll say console.log password at c. Okay, so this is my first little demo. Is let me run and print out all of these things. Okay, so here we go. Here's the full string. So ignore the HTML up here. It's not important, but you can see each one of these letters let me in. Now, one of the things that I hope that you know about from your previous or from your other courses is that every character that goes into a string inside a computer, of course, doesn't actually get stored as the letter C. It gets stored as a number. Okay, in particular, its ASCII value. All right, there's a function built into a string called car code at, and the way how it works is you provide as a parameter the position. Okay, so this would be C at 0, C at 1, and what this is going to do is this will tell me the ASCII value. So if you remember, the password is let me in. Okay, and if I save this and I come over here and I load the page, you'll see 108, 101, 116, etc., etc., etc. And if you take a look at, say, an ASCII table, okay, let's pop open the first ASCII table that we find. You'll see here that the letter lowercase l happens to be the number 108. The lowercase e is 101. Lowercase t is 116. All right, let's go back and take a look at my output. Sorry, not this one. I'll close that. Okay, and of course what I've got is 108, 101, 116. Perfect. So these are exactly the values. Now, I'm not interested in storing these values for the password, but here's the trick that I'm going to do. Let's have this extra variable called sum, which I'm going to start off as being 0. And what I'm going to do is I'm going to, inside this loop, rather than printing the value, I'm going to say that sum is equal to sum plus password car code at C. Okay, and then what I'm going to do at the end is I'm going to console.log the value of sum. Okay, now let's take a look at this. All right, so take a look at this. The sum of all these characters happens to be the number 750. Okay, here, let me pop this open. You don't need to see that, but let me open up a new text. Okay, sorry, let me close that one up. Okay, that was just my exercises for the day trying to decide. Okay, let's make this font a little bit bigger, and we'll say let me in happens to be the number 750. All right, now there were some other passwords in here. Yeah, they were all pretty terrible passwords. What do we have? 12class34. All right, let's go back over here and change this password to 12class34, and let me save it and reload and do the same type of calculation. This is 736. Okay, so I put that here in the text edit. 12class 34 is number 736. Okay, so what these are, this is the original plain text password, and this is some kind of an encoded password. What it is, it's all the characters are being reduced to a number. And this is actually an absolutely terrible thing, but this what I've done, this is a mechanism called hashing, where you're taking a string and you're turning it into a single number. Now, the reason why I say it's not very good is, well, we'll show a couple of examples in a second. You know what, since we're here, let's fix the other ones. What were the other passwords? We have the word password, fluffy, and QWERTY, so password. Let's save this one so at least we see all the values. So password ended up calculating to 883. Fluffy is a number and QWERTY is another number. Okay, so let's actually check all of these ones. Okay, so Fluffy. Okay, load up this one. This is 652. 652, and finally QWERTY is the final one. QWERTY T, there we go, and load this one up, and that's the number 684. Okay, 684. Okay, so the idea is rather than storing those passwords, let me in 12class34, password Fluffy and QWERTY, what I could do is I could come over to here to my actual CMS system, and rather than having the word let me in, I could store the password hash 750. And instead of the 12 class 34, I could store the password hash 300 or 736 instead of the word password. I could store the number 883 instead of fluffy. I could store the number 652, and instead of QWERTY, I could store the number 684. Okay, so now what have I gained by this compared to storing the actual values? Okay, well, take a look at this. If somebody got their fingers on the actual database table, can they actually tell what the password is? So take a look at this. All we know is that the password hash is coming out to be the number 883, but we have no idea what that password actually was. Okay, so because we have absolutely no idea what the password was, there's no way for us to actually recover the password. And what this is a mechanism called password hashing. All right, so what I'm going to do is I'm going to get you to pause this video, and I want you to refactor the authentication to use the summed value, or the summed ASCII value password hashing. Okay, so please go off and do that. Pause the video. It shouldn't take very long. I'll leave it for a couple of seconds for you to pause. Then I will come through and I will actually demonstrate the solution to this one. Okay, so of course what I mean is refactor the authentication. It means pass in the password, but you don't actually compare the password directly. You compare it against the sum. Okay, so I'll pause here. Okay, so hopefully you didn't find that very difficult, but just in case you bumped into difficulty, this is what I would talk about doing. So when you come in here, I would still continue to do the attempt login. Okay, I would still attempt to do the authenticate, and I would still pass in the password that the person typed. But the difference is when you start looking these things up, you can't just do this anymore. You have to start doing a little bit more work. So let's call this the hash value, which is 0. And I'm going to say for let I equal to 0, while I is less than C password length, I plus plus. I'm going to say hash plus equals C dot password car code. That's much easier when it actually gives you a bit of help. Car code at this, and that's going to build this up. And all that I'm now going to do is I'm going to check to see whether or not the password hashes into the same value. And if it does, then it should let us in. So now, of course, the problem is as well, I remember my password. So I'll have to remember this thing over here. Okay, so that I think is in the same order. Okay, let me get back to here. Let's save the file. And of course I'm looking for CMS, so I've got to go back to here and call this CMS. Okay, and let's save it. Let's go over here, load up the page. Okay, first of all, what we need is somebody's username. So let's actually try a real username. Let's try this one right here. Okay, and I believe that this is actually the name Fluffy. Okay, so let's come in here, we'll paste this in, and if we type some random junk, it says show error message. Okay, that's because I typed a pile of random stuff. All right, now let me actually type the word fluffy, and see whether or not we get in. It says show error message. Now, was that just because I completely messed things up, or did I make a mistake somewhere? Ugh, okay, well, I was hoping it wasn't QWERTY, was it? No, I'm not even sure. Okay, no, it still says show error message. Okay, in that case, a little bit of work has to happen. Okay, well, let's see if we can track down what's gone wrong. Okay, let's pop this open and let's set up the breakpoint to see whether or not we've actually got the correct thing as we're calculating the hash value. Okay, let me set a breakpoint right here and let me type in Fluffy. Okay, and here we go. Here's the password Fluffy. Oh, now I see exactly what it is. It's my C password is actually the hashed version, so that's completely wrong. I should have been hashing up this PW parameter. Okay, sorry about that. Wrong variable. Sorry. Take the PW and hash PW value. Okay, so let me take away the breakpoint. Hit this. Of course, let me reload the entire page. Let me put this down here. Okay, and here we go, and let's type some random gibberish. Okay, good, it says show the error message, and now let's actually try Fluffy. and it still says show the error message. Really? Was there something else? Well, I guess this is what I get for doing real-time. Didn't I just change that? Did I forget to save it? pw.length, not pwd. C's password is equal to the hash. I think maybe now I've got it. Okay, well, I'm willing to try it. Okay, once again, random stuff. Okay, good. That says the error message, and finally. Oh, okay, finally. Sorry, that took a couple of extra times. Okay, so finally this ended up working. So you see what's happened is I passed in the original password, and I went through and I did a hash by adding up all of the character values, all the ASCII values, and I decided whether or not that was the correct thing. Okay, now, here's the thing that I want to point out. Take a look at the following word. Okay, we know that the word fluffy. Okay, let me make a copy of this one. We know that the word fluffy ends up to the values 652, but you know what else adds up to the same number of values? FFFLUY. Okay, and guess what? Because it's exactly the same value. So you know what I'm going to do? Let me copy this entire thing. Let me go over to here. Let me reload the page. And I'm going to paste this in as the password. And, well, of course, now I forgot my other one. And I'm going to get this one right here. Okay, so there's the customer name. And what I've pasted in here, I've pasted exactly FFFLUY. And guess what? I also get in. And what this is, these are two different strings that happen to collide and give exactly the same hash value. This is one of the reasons about why this particular idea of adding up values like this, the ASCII values, just do not work. Okay, I mean, it's a very simple exercise. In fact, there's all kinds of other ones. For example, imagine this. Okay, so what do you think? Let's see. Let's write down the word fluffy again, and 652. And here's what I'm going to do. Okay, so now the question is what letter comes before F? Okay, that'd be the letter E. Okay, what letter comes after Y? Well, Z. Okay, so guess what? The word eluves happens to also give you exactly the same thing. Okay, so here we go. I've copied and pasted eluves. Let me go back in and grab this person's username again. I should have used easier usernames for this. And guess what? I can also get logged in. And of course, all that I've done is I've just picked I've lowered the first ASCII value by 1. I added 1 to the final value, and that gave me exactly the same thing. So this is why this particular mechanism of going through and adding up values it just ends up not working. Okay, all right. So although it's sort of an interesting mechanism and it prevents you from seeing the actual values, it just ends up not being all that secure. Okay, but instead, what I'm going to do is I'm going to give you kind of a much better solution and something that is actually used and is out there. Okay, there's a handful of mechanisms that I want you to go off and just do a quick Google search. Maybe you've seen these names before. There's a very famous one called MD5. Okay, and what this is a hashing algorithm that takes strings and it turns it into a single number. It turns out that this one's not particularly good, and about 10 years ago they said stop using it, and well, most people have, and I'm certainly not going to. There's another one called SHA-1, which ended up being a different hashing algorithm. Again, I'm not going to get into the details about how these work, but one of the things to point out about these types of functions, in fact, I'll demonstrate online, changing up the order of the letters makes very, very different hashes. For example, if you want to, you can come over here, you can say MD5 online, and somebody will probably show you what one looks like. Okay, so here we go. So you type in a word to get a hash of it. So let's take a look at the word fluffy and see what the hash looks like. Okay, here we go. So here's the hash for the word fluffy. This is an MD5 hash. So fluffy gets turned into that number, which looks certainly a lot better. And if I start flipping things around and say FFFLUY, okay, you can see now that this one, FFFLUY, is something very, very different. And that's because the hash is not only based on the ASCII values, but it's also dependent upon the positions. Now, the latest thing happens to be these things called SHA encryptions, and in fact you can see that there's something here called SHA-1. Guess what, there's also something called SHA-256, and that's the one that most people are using these days. And here's an online thing, and once again we can write out the word fluffy, and you can see now that we've got this word here. In fact, you can see there's a whole pile of them. They keep getting even bigger and bigger. 256, and the reason why I picked the 256 is because that's something in a library I'm going to show in a second. And you can see, first of all, that the size of this is massive, so there's less of a chance of a collision because these things happen to be bigger. And FFFULY, this happens to be this number right here. So let me paste this in, FFFULY, LUY. Okay, and again, you can see that these are just really, really big, so there's less of a chance to bump into each other. And what they're based on, they're based not only on the actual string values, but also the position within. So the fact that this is an L followed by an F is very, very different than it would have been if it was an L than an any other combination of things. Okay, sorry, so F followed by an L will be very different than an L followed by an F. Okay, now if we want to make use of this, okay, how could we do this? Okay, unfortunately, there's nothing built in directly into JavaScript that allows you to do this, but I'm going to show you a nice library that somebody's produced, and it's pretty reasonable to use. So I'm going to get you to do one final exercise with the hashing. Okay, and what you'd want to do is you want to do exactly the same thing I'm about to do here. SJCL. Okay, this is a standard JavaScript crypto library from Stanford University. Okay, and let's see if I can actually find the correct one to download. Demo page. Is this the one? Is this the one that I'm looking for? It's like everything else. There's like easy ones to download, and then there's ones that are absolutely terrible to download. Let's look for the word download. Okay, file clone or download. Unfortunately, a lot of these things are really unpleasant. For example, okay, let's take a look at Core. You know what? Although these work, I'd actually recommend not taking those ones. I don't know why they make these things so tough to track down. Let's have for min. Okay, I think this one right here will be fine. Okay, so let's take this. Okay, you know what, this will be perfectly fine. Okay, so see what this is. And this would be something new, by the way, I don't think I've talked about yet. So what this is a library. It's the SJCL library. Here's the minified version. In fact, you know what, we'll even take this one. So let me highlight this one and we'll say copy the URL. Okay, and I'm going to use this library in my file. Okay, now how do you know to use a library? Well, you come over here to your HTML file. Now, this is one of these things I unfortunately haven't had a chance to try yet. And you say script, and you say src is equal to, oh, there it is. You load the entire thing up from somewhere else. Yeah, they don't have to be copied to your local server. They can actually be put anywhere else. Okay, now, just before I have a chance to try this, let me save this and reload this just because I want to make sure that I've done the right thing. And I just want to come over here, and it looks like the file is loaded without any problems. And sorry, just let me type SJLC, SJCL. Okay, good. Yeah, this is actually the right version. And you can see there's a bunch of things, including this hash built in called SHA-256, and that's the one that I want to use. Okay, so here we go. In order to make use of this, here's what we could do. Okay, back to my map demo. So rather than doing all of this thing, here's what we're going to do. It turns out it's very simple. So I'm going to have this thing called sum, and here's how you use it. SJCL codec hex from bits. Oh, now where on earth did this come from? Yeah, obviously I did a little bit of work on this before because this is not something you're likely to bump into on your own. Okay, along with password. Okay, so this is the way how it works. What you do is you call sjcl hash SHA-256 and you hash the password. And what it does is it provides it in the wrong form. So here, let me put it in this way for a second so you can see. All right, that actually does a hashing function. But the thing is that when you take a look at, no, am I loading the wrong one? Of course I'm loading the wrong one. How come you didn't tell me? Map demo. Okay, here we go. So you can see here, this is what the hash looks like, but the hash looks like a whole bunch of numbers. Well, because it's in binary format. So in order to make the thing kind of look more like a normal everyday string, probably what you'll find is if you turn it from the bits into this format, it'll look a little bit more like a string. And there you go. There's the actual hash of the word QWERTY. Okay, so in fact, we can even go back and verify this. QWERTY, now I haven't checked to see, starts with 6.5, ends with a C5. Let's take a look and see if that's it. Starts with a 6.5, ends with a C5. Ah, excellent. Okay, so here's what I want you to do. Okay, so you've had a chance to see how I was using this. So I'm going to say, not pause this video, but I'm going to say after this video, I want you to do the following. Fix your authentication mechanism to use SHA-256 instead of the sum of ASCII, okay, which turns out to be a really bad thing. Okay, so of course use the SJCL library just as I demonstrated. Okay, so what does this mean you'll have to do? Well, you would end up having to do a couple of things. Number one, you'll have to fix all of these things. Okay, all of these passwords will have to be encoded in SHA-256, and of course you'll have to make some changes down here so that when you're calculating the hash, you're actually setting up the values. Okay, all right, so that's the end of this video. Let me leave it back here. Okay, and I've got one final video. I don't think it's going to take very long, probably about 10-15 minutes at most, and I'm not even sure if I'm going to get you to try the exercise in the next one, but I'm going to encourage you to do it. Okay, but yes, please do try this one because this is the way how passwords actually need to be stored and how it works. Oh, and by the way, a really important thing, you know, from right here. Sorry, wrong one. Here we go. You know already that people like the IT support staff, if you forget your password, they can't actually get the password back for you. They can set a brand new one, but they can't get it back. And it's because of these SHA and MD5 hash functions. This is actually the reason why you cannot recover passwords. They are known as one-way ciphers. So you can take something and encrypt it, but you can't bring it back the other way. Okay, all right, so that's all for today. I will leave you with the screen right here.